Joel, we are live.
Can you hear me now?
Yes.
Yes. Okay. Not coming through on my phone, only coming through on the computer, which is very bizarre. Okay. Well, anyways, good morning, everyone. Sorry about that. Welcome to this morning's webinar. We're glad that you're joining us today for a new topic. This is the first time we're presenting this one, so we're excited to do so. This is new for us, and hopefully we'll learn a lot from today's session. My name is Joelle Guinette. I am the Territory Manager for Eastern Canada, so Ontario to the Maritimes. Michelle Cloutier is the Territory Technical Manager who puts these webinars on with me. But today we have a special guest. John Milbury is joining us, and I will introduce him in just a minute. He will be presenting Introduction to CAM, which is our topic for today's session. So why are we presenting this? Well, one primary reason for presenting this is because SOLIDWORKS 2018 has released in with our products, our SOLIDWORKS Standard, our SOLIDWORKS Professional, and our SOLIDWORKS Premium. We are now offering SOLIDWORKS CAM Standard with those subscription licenses. So if you have those licenses in 2018 on subscription, you have access to SOLIDWORKS 2018 CAM Standard. So we thought we wanted to let you know about this, what it is, what you can do with it, what it can get for you. SOLIDWORKS is going very much towards more solutions for model-centric design for what we call smart manufacturing, or we also call digital manufacturing. So different names that you're going to hear about this. CAM, as you can see, is right in the middle of all that, is a huge piece of it. And it centers around other applications or other solutions that we've introduced, such as topology optimization that you may have seen in our simulation suite, such as MBD, which is the use of PMI information to help create 3D modeled information and try and reduce some of the 2D layouts that are necessary at your company or drawings. Into managed data, obviously our data management is part of the digital structure, so a PDM is always at the center of that as well. And then automated inspection reports and automated inspection, if you want to take a step further, all part of this smart manufacturing and digital manufacturing. So CAM is a huge part of that. It's right in the middle. I won't say any more because that's the whole purpose of today's session, and I won't take John's thunder away from him. John's been with SOLIDWORKS for actually 22 years now, and when we introduced CAM, and apparently it came as a surprise for a whole lot of people who knew him, that his previous life before SOLIDWORKS was actually in manufacturing. So John was at Halliburton a number of years in CNC programmer and manufacturing systems coordinator roles, and therefore obviously brings to us a lot of experience in this CAM position, and he's the technical sales director for manufacturing products now at SOLIDWORKS, which is great. So he's going to take that experience that he has, mix it with what SOLIDWORKS has introduced, and he's going to give us a great introduction to CAM today. And if you have any questions, there's a chat box on your right-hand side in the GoToMeeting panel. You can write your questions. If there's time at the end, we will address them. If not, we will address them offline afterwards. There's also a few handouts that you can see there that you can take if you want, download and keep for yourself. And I will come back at the end and give you a little more information on possible next steps if you want some more details. But with this, I will transfer it over to you, John.
Well, thank you so much, Joelle. This is John Milbury, and it's a pleasure to be with you today. Let's get right to the heart of the matter. Let's take a look at our agenda for the next 55 minutes. We're going to take a good hard look at using setup templates to help automate the setup of our CNC programming environment. Next, we're going to take a look at interactive feature recognition that's inside of SOLIDWORKS CAM and how it's so non-traditional from other CAM programming systems. Next, we're going to look at the big, incredible power behind automatic feature recognition. Again, very different than other CAM systems And you can think of this similar to a rules-based system, just like SOLIDWORKS. Next, we're going to take a look at linking and combining manufacturing operations. And finally, we're going to take a quick overview of the technical database, the TechDB, which is really the brains behind our entire product. And finally, we're going to wind up with some post-processing. I'm going to introduce you to how that works and give you an overview of how you can actually create and write your own post-processors. So with that, we're going to start out with using setup templates. And let me show you the automation. One of the things that you want to pay attention to with this is that it's really the way that we're going to combine the SOLIDWORKS environment along with the SOLIDWORKS CAM. So let's take a quick look. Here we've got a part that we're going to manufacture today, and we're going to machine this using SOLIDWORKS CAM. One of the most important things with a SOLIDWORKS CAM or any NC programming system is really a naming convention for your files. This is going to be important, so I'm going to start off there. I'm going to show you a process plan sheet. The process plan sheet is really just kind of, think of it really as the plan to manufacture the product as it goes through the shop floor. Today we're going to be focused on operation number 030, which is the machine setup on a machine called a 770, and that's going to be our machine or our cost control unit. And what we're going to do is we're going to create different file naming conventions based on our process plan sheet. So today's documents are going to be called 14T5209, concatenated with the operation number, and then concatenated with the actual machine CCU. This is going to allow people with PDM or anybody with access to File Explorer to quickly search and find the required manufacturing documents. So let's take a look at how that's going to work. We're going to begin by using the design library. And we're going to use a series of setup process templates. And from here, this is a very small part, so we're just going to manufacture this in a very small vise for a Tormach 770. And here's the actual vise that we're going to be using. One of the things we want to do is we want to open up a drawing, because one of the great things is we've got the power of SOLIDWORKS here. We're going to be able to utilize drawings and have this automatically populate. And again, it's going to be a fixture setup sheet that's going to go to the shop. So let's begin with our new naming convention. One of the things that we want to do is we want to go ahead and use that and save these templates out. So we're simply going to call this, again, we're going to use that concatenation. So I'm going to also add in the operation number as well as the machine number. And we're going to include all reference documents. Let's go to advanced, and what we're going to do is we're going to specify the proper folder. Pretty simple to do here. And then we're going to come in and we're going to rename the assembly to match the drawing number. And that looks like that's going to be complete, and we're just going to come in and we're going to do a save all. And so this is going to retarget our setup process documents to this new number and new name. And there we've got it. And one of the things I want to show you is we're just going to come in real quick, and we're just going to go into our title block. And while we're here, let's go ahead and let's rename this. So again, we're just going to come in and fill in our title block with the new name, excuse me. And here we're just going to call this a spacer. See if I can type quick enough here. Program by, we've got a pull down. That's going to be me right there. The program date is today. The operation, of course, is going to be 030, and the machine number, or CCU, is going to be 770. We're just going to hit apply. And there we've got our title block filled out, or at least partially. Let's jump on back now to our actual assembly. And what we need to do now is we need to populate it with our part. So we're just going to come up and again, just using SOLIDWORKS, we're going to go to an Insert Components. And let's go ahead and let's bring that in. We're just going to float this on out. And what we're going to do is we're going to place this in our vise precisely. One of the things I want to show you is inside of the templates, if you go to Favorites, we can select on a plane for the bottom of the part. And we can select on the bottom of the part and create a coincident mate. Now this is great, very simple and easy to do. One of the things I want to turn your attention to is actually the stock outline that you see here. And what we're actually going to do is something that's a little bit different than what most CAM systems do. Most CAM systems just use a plain bounding box, and you wind up with very unusual numbers over here. It's basically a raw material size that you can't purchase. Let's take a look at what we can do here. Let's just go ahead and let's run our auto size stock. And you can see that we come in at 3 by 3 by a ½ inch. And believe it or not, the 3 by 3 is actually a stock size that you can purchase. And you can purchase this as an extruded bar, and then you can cut these in ½ inch segments. And so this is really the power of this. If we take a look, we can also get a little bit more granular if we need to. For example, let me show you. Let's come in and let's take our saw cut and let's put it to 1/16 and apply. And once again, we'll go ahead and we'll resize that stock. And you can see now that it's come out a much, much tighter number, but in reality, we really can't purchase it in that size. Let's come back and let's put this back. And again, we're just going to go at ½ inch increments. And just rebuild that. So that looks great. Let's come into our top view and let's go ahead and let's place this. And this is going to be pretty easy to do. I'm just going to use drag and drop, right? I'm just going to kind of, might want to rotate this around and get this kind of situated where I want it. I'm just going to place it within there. Now at this point, all we're going to do is just fix this in place. And now you can see we've got a pretty good layout using this template. But what's really important is that we've got a drawing that right now reflects all of this information for the machine shop. One last thing I want to show you here on this side is the ability to come in and set our XYZ location. And again, this is going to be done on the drawing as well as within SOLIDWORKS CAM. So let's come in and let's take a look at how we do that. If we just wanted to do an edit feature right here, we could come up and just re-specify a new location. And just like that, we're able to move that XYZ 0 around. I like the original, so I'm just going to use the undo, and we're just going to go right back. What we're going to do is go over now to the drawing, and let's take a look at what's happened. This drawing is going to fall out somewhat automatically. You can see that the part right now is shown in the exploded view. And you can see where it is very, very graphic, and it shows the operator exactly how the material and everything is placed around the part, as well as these grippers. And you can see here also that we're calling out where the machine 0 or G54 is going to be located. It's very easy to see. And then also down here, we've got kind of a gripper view. So what we're doing is we're actually using Mighty Bites tail-on grips. They're really, really cool. And what they allow us to do is to grip just on a tiny amount of that stock and actually have the part ride just above that, so that we can kind of machine on all 3 sides at once. Great functionality and very easy to use. So let's come back and let's continue now. We're going to come back to our actual assembly. And here what we want to do is we want to go into SOLIDWORKS CAM. So with just a button click, I've kind of done that. And what we'll do is the very first thing that we need to tell SOLIDWORKS CAM is we've got an assembly here. What we want to do is we want to tell it what part we're going to machine. And very quickly and easily done. The next thing that we want to do is come over and probably do what we would call a mill setup. So I'm just going to go ahead and just tell it which way Z is, the direction for the Z axis. Pretty quick and easy to do there as well. Next, let's come in and let's use the stock manager. And what we're going to do is we're going to get this synchronized. You can see that there's the bounding box I talked about that really produces an unrealistic stock number that you can't really purchase. So here's what we're going to do. We're going to expand out the feature tree. And we're just going to come in here and we're going to select our stock XYZ sketch, and then we're going to select the maximum Z. And you can see that now our stock is located on there. It's great and simple to do. We're set up, and of course, the coordinate system is pretty much ready to go as well. And with that, we're pretty much ready to, we've completed our setup. And once again, we've got a drawing here that's in sync and is going to be updating with everything that we do. So to conclude and kind of give you an overview of what we just saw, when using setup templates, there's some real advantages. One is that we can rename these templates, and an intelligent naming convention, right, is going to really help programmers, machinists, as well as engineers be able to search effectively and easily for NC documents. The other thing that you saw was that the setup templates that we're actually using aid in the machine setup analysis. So you can see that very easily I can find out exactly where all the components go for the setup and how the actual part sits in the stock and how the stock sits in the vise. Very important and easy to do. Once again, we're going to communicate that information down to the machinist via machine setup drawing. It's pretty self-explanatory and really gives them a great guide. The big thing it does is it removes and eliminates errors, especially in the setup area. And then finally, one of the things I want to tell you is that most of you know that API for SOLIDWORKS has always been there, but there's also an API that ships with SOLIDWORKS CAM with the ability to actually call different CAM features and capabilities. So the API is available for SOLIDWORKS CAM and SOLIDWORKS and is basically included. And one of the things that you saw me do with it is I use the auto size stock to help automate my company process. And the big reason for that is that we wanted real-time accurate material lengths that we could order, okay? Next, let's take a look at interactive feature recognition. And while I get into this demo for interactive feature recognition, I want you to pay attention to the fact and notice that I never have to select any geometry. So unlike a standard CAM system, we're going to let SOLIDWORKS CAM do the heavy lifting. So let's take a look at how we do that. So one of the things that we're going to do is we're going to machine basically the outside of this part, and we're going to do what's called perimeter machining. And I'm just going to select on a feature that I want the system to recognize. And basically SOLIDWORKS CAM has gone in and analyzed, it knows where the stock is, it knows where the solid model is. It's going to create what we're going to call a feature. And so let's go ahead and select OK. And right away, it's created what we call a perimeter open pocket feature. It's using a machining strategy automatically called rough finish. Let's come in and let's generate what we call an operation plan. And the operation plan is simply, now that we have a feature, how are we going to machine it? And our tech database has told us that our machining practices dictate that we're going to use a rough mill as well as a finish mill to get this machined. Now, the other thing that we need to do is just generate our tool path. So let's go ahead and let's generate that. And just like that, we've got a tool path. It's quick and easy. And the important thing is that I never selected any geometry. All of my best practices for machining have been pulled out of the tech database. Let's come in and let's take a look at how we might plot this. So let's come in and let's just do a step through toolpath and give you a quick idea on how this looks and what we can do with it. Slow down the speed just a little bit, and let's just let it play. So it just gives me a really rough idea of how the tool moves about on the toolpath. And that's great, and I will use that from time to time, but what I really like to use is I like to use what we call our simulation tool. One of the things you saw right there was you saw basically we're using a 1/4 inch flat end mill. What I'm going to do is come in and do an edit definition on this. I'm just going to show you how we're going to be able to tweak a few parameters. If I go over to optimize, you can see that my total time right now to rough that out is 5 minutes. Now that is a lot of time, and I believe that I can probably improve on that. So we're actually going to do two things. Let's come over to our tool and let's use a little bit larger tool. We can go into our tool crib. And our tool crib is just a set of tools that we've got defined per machine that actually reside in our tech database. And whenever we create a feature or a feature becomes recognized, it goes in and it automatically pulls the right size tools from the tech database. So it's pretty interesting. What I'm going to do is obviously a 1/4 inch end mill is going to work. I want to select a slightly larger one. We're going to use a 3/8 end mill. We're machining 6061 aluminum, so it's going to be 2 flute. I'm just going to go ahead and select that, hit yes. And what I also want to do is I'd like to use some high-speed machining techniques. So if we come over, I can actually take the machining strategy and change it to high-speed volume mill. Come over to my feeds and speeds. And what we're going to do is we're going to use the volume mill technology expert to go ahead and choose between a conservative or an aggressive set of feeds and speeds. I'm going to go to conservative. I'm going to hit OK. I'm going to go ahead and preview this. And you can see we get a much different tool path. So high-speed machining really allows us to take kind of arc-like motion rather than hard left and right motion, so it's easier on the machine. It does a constant volume loading, and it does the full length of the flute typically. And so what this does is it speeds up the entire process and also saves the life of our tools. So you can see that one of the things, let's come back to optimize, and you can see now that we were at 5 minutes, we're now below 30 seconds. What an incredible time saving when we go to high-speed machining. We're just going to hit select OK. And let's come in now and let's go ahead and let's run this with what we call a simulation toolpath. And this is a great tool right here. And I'm just going to say go to next operation. And we're just going to take a quick look at what some of these high-speed toolpaths look like. You can see the full flute is engaging the metal. And you can see it takes arc-like cuts. There's no hard left and right motion. And so it's this technique that allows us to go from that 5 minutes worth of roughing down to about 30 seconds, tremendous saving. Now, the other thing too is, remember, we produced 2 machining operations for this feature. The other one is going to be actually to finish the outside profile. And the way my tech database is set up is it's going to take a certain percentage of the diameter and it's going to come down. And with cutter compensation engaged, it's going to go ahead and finish out that entire profile. I believe there was 10 thousandths of stock left there. One of the things that we can do as well is we can use this display option to show the difference. How finished are we right now? The green, always remember that the green means that we're actually to the actual size of tolerance of the part itself, okay? So that's some great capabilities. One of the things that I want to end with this session right here on interactive feature recognition is to come to the feature tree and do a slow double click. And what you can see is we get that same functionality to rename our features or our operations the same way that you get it inside of SOLIDWORKS. So that's going to be a rough perimeter, and this is going to be a finished perimeter operation. And just like that, we've completed that. Let's jump back. So let's revisit a few of the things that I just showed you. Basically, feature geometry was automatically selected. You know, I didn't really have to pick any of the geometry. And what this does is this removes really the tedious mouse picking that you see in other CAM systems. The other thing that you saw was once we're feature-based like this, we can use the TechDB to find out how to actually machine a particular feature like a perimeter. In this particular case, the tech database automatically chose the correct feeds, speeds, and machining parameters. I have always asked the system and taught the TechDB never to use high-speed machining unless I interrupt it and tell it to do so. So basically it worked great. In this particular case, I wanted to override it and use high-speed machining. So again, creating these operations from that single feature is just saves time as well as money. And finally, you got a quick look at high-speed machining and what it can do. You saw the dramatic difference from 5 minutes down to 30 seconds. So it can reduce cycle times by sometimes 70% or even greater. And just by the basic constant volume of metal removed on the tool and the full tool length, its ability to dissipate heat, what it does is it increases tool life by 200 to 300%. You know, which is just an incredible capability. So now that we've looked at interactive feature recognition, let's look at automatic feature recognition. And you can see where interactive, I had a lot of automation, but I only addressed one simple feature on the part. Automatic feature recognition gives me the ability to address a whole set of features at once on a part. So let's take a look at that. Before we get into automatic feature recognition, what we want to do is just take a look at our options for CAM. And these options right here are going to be the feature types that we're going to recognize. Now I know from looking at this part that there's certain features that I want to have recognized. Obviously I don't need the perimeter feature, we've already done that. I'm not going to need a face-off routine either. So what we're going to do is we're going to select these different feature types to be found and identified. Let's just hit OK. And then with a button click, we'll hit Extract Machinable Features. Once again, one of the huge powers of SOLIDWORKS CAM, what makes it so fast, is the ability for me not to have selected all this geometry. Take a look. I've got these different operations that have been created along with the toolpaths by selecting no geometry at all. Just phenomenal capability. So let's take a look real quick. We're going to take you through really the first couple of operations. We can see here that there's actually a small boss that we're going to be machining here. And we've also got a hole here in the center that we're going to be cutting out with an end mill rather than a drill. So let's come in and let's address these real quick for you. So we're just going to come in and I'm going to say for the rough, we're just going to call this a rough boss. And I like to rename this. It's not necessary, but it really gives me a better understanding of where I'm at and how I'm processing everything. Let's come in here on this rough mill and let's call it rough hole. And we're going to rename the contour, oops, I think I got that wrong. Yeah, let me rename that. That's going to be rough pocket. Okay, let's go here. There we go. That's going to be rough hole. And let's come here and let's do a finish hole. And of course, after I rename this, what we're going to do is we're going to verify this once again through Simulate Toolpath. So we want to look at this really close. This is part of the debugging operation. Again, I want to go to next operation and look at this operation by operation. We've already done the first couple, so we're just going to speed through that very quickly. And what we want to do is let's take a look now at this rough boss and what it looks like. Let's watch it closely. We've got a 3/8 end mill here, and we can see that that's down right here, the 3/8 flat end mill. You can see that it's doing some pretty standard type of pocket in roughing routine, which is exactly what I want my tech database to do. Now I do have a final pass on this, and there's a final profile pass there. And then also I've got a machine island top turned on, so it's actually going to kind of machine that. Let's take a look real quick. We're going to come in and do a quick finish contour there on that. You can kind of see what we've got up to this point. The green again says it's finished size. We want to go now to the whole operation. What you're going to do is you're going to see kind of a helical plunge to kind of get down into this aluminum. And we're going to do that at a couple different levels. And this is with a 1/4 inch flat end mill. We're going to come back with the same 1/4 inch flat end mill. And what we're going to do is we're going to finish off and finish this to size. So there's going to be about 10,000ths of stock in there. So let's take a look real quick at what we've been able to do. And you can see that really the only thing that we've got left is really just these pockets and the top of these tabs. And then there's some holes that are in these tabs. So I hope you can agree that automatic feature recognition, look at all this information that it just gave me. It's phenomenal capability. Automatic feature recognition uses some of the same technology that you might have seen before in FeatureWorks, as it goes through and takes a solid model that could be brought in through STEP or IGES, and it makes it parametric by recognizing faces and creating sketches. So this is some similar type of technology. Let's come back and let's recap for automatic feature recognition. You know, the great thing about it is that it quickly extracts manufacturing features and it saves time over mouse picking. And again, it automatically selects tool. It defines your best in class machining operations. And this is a huge, huge advantage over traditional CAM systems. Next, just to give you a quick idea, SOLIDWORKS CAM can recognize on a mill over 20 different manufacturing features. And you can see the power of what I've done. And really what it does, it removes the drudgery of day-to-day programming where you're constantly picking the edges of a pocket or the face. It just removes that. Let's talk about linking and combining operations, because what I want you to notice is as we get over into the actual operations tree, there's a lot of operations there. And we can kind of clean that up. It can get I don't know, get kind of really long. So what we're going to do is we're going to clean that up a little bit. Let me show you how we do that. So if we take a look, I've got a rough pocket right here. And then we've got a contour mill, which is basically the finish of the pocket. Then we've got another rough. Then we've got another finish. Then we've got another rough. And then we've got another finish. Now these pockets are not the same size, but they are similar. And my machining parameters to machine this are going to be identical. So what we can do is we can do what we call a combine operations. And we're going to do that. I'm going to show you kind of a little trick that I like to do. Here's my first rough pocket. If I come down here to my other rough pocket, I'm just going to drag and drop it on the feature tree and just place this operation right there so that they're back to back. So this is the same type of familiar capability that you've used inside of SOLIDWORKS to reorder features. So here you can see we've got all three of these now right next to each other. And all I'm going to do is shift select through them, do a right mouse button and do combine operations. So what I'm going to be able to do is combine these out into a single operation. And you can see that now that's rough pocket. So what's interesting is that I can control all three of these pockets now with a single set of parameters. So if I wanted to change my feed rates or tweak them slightly, or even my spindle speed, I could do that now just by making a single change to one of this operation, and it can control all of them, okay? Let's go ahead and you can see that my contour mill here basically the finished pockets, they're all lined up as well, right in a row. And again, the very same thing applies. So let's just hit combine operations, and we'll just hit OK. And let's go ahead and let's change this to finished pockets. So great. Let's come in. We've got rough mill right here that we've got, and we've got this each one of these tabs. And we want to do the same thing, but this time I'm not going to bother to reorder. It's really not necessary. I'm just going to go ahead and control select each one of these independently and just do a right mouse button and say combine operations. We'll hit OK. And you can see now we can come in and just say rough tabs. And that's great. So that's combining operations. Now there's some other types of operations and other ways that we can sort by tools and a whole lot of other things. But let me show you this real quick. This is a great example. If we come down here, we can see that my finish tool took 2 passes in XY to remove that 10 thousandths of stock. And you can see that it didn't really space those out. I was kind of at my max. So let's come in and let's make a change to this. Let's just edit the definition. And what we'll do is change these machining parameters just a little bit. Let's just go to contour, and all I'm going to do is put this at 25%, do a preview, and you can see it's spread that out now pretty nice, and we'll hit OK. So what I want to do now is I'll show you linking, and linking doesn't really combine operations, but what it does is allows other operations to inherit the properties of another one. So let me show you. We're just going to right mouse button on this, and we're going to say link operation. And I'm going to choose my contour mill 8 and my contour mill 9, and we're just going to say link. Now I also need to regenerate toolpath on these. And you can see now, if we come over and look at this, you can kind of see that each one of these contours are kind of spaced apart. So what it really did was inherit while maintaining them as separate operations. And this is important, very important for flexibility when you're in C programming. Now, it just so happens that I could have combined this, but I wanted to show you linking. So we'll combine that now. We'll just say combine operations, hit OK. And for this, we're going to say this is going to be finished tabs. And there we have a really, really nice set of operations with descriptions built right in. Let's take a look at how all of this plays out now. Let's come in and let's do another analysis for a simulate toolpath. And once again, for the ones that we've already looked at, I'm going to go through very, very quickly. And we'll just go to next operation. And up to this point, we've seen all of this. Let's go ahead and let's take a look at how we machine those tabs and the pockets. Let's come up on the pockets just a little bit with the speed. And I'll get that going. Again, you can see the high-speed machining tool paths right here. So for pockets, I did allow high-speed machining to be the default. Let's come in and let's just finish up each one of these profiles. That looks great. And now let's take a look at the tabs themselves and see how that roughing is doing. And you can see we've roughed those out with high-speed machining technique as well. Let's just come in and let's finish profile each one of these. And again, you'll be able to see over here that fine adjustment that we made so that we're getting a nice dispersion of our cut. And so far, so good. This looks great. The only thing we've got left is to do a quick run of center drilling. And then what we're going to do is go ahead and drill this to size. And with that, if we take a look now, we can see that we've completely finished. These little striations that you see are just the fact that I haven't set my tolerance very, very tight because it takes longer to process, but this is all completely machined to size now. So let's come back for a moment. And linking and combining operations, let's review what we just saw. So reorder reordering operations and really features, which I didn't show you, is quick and easy using drag and drop, and it's the same familiar techniques that you're used to using in SOLIDWORKS. Combining operations really allows for control of a single set of machining parameters rather than multiple sets of machining parameters for different operations. Great capability, as you saw. And then, of course, linking an operation really allows it to inherit the manufacturing strategies and machining parameters of another operation. All of this gives the NC programmer a lot of flexibility and capability in determining how the NC program is going to be structured. Next, let's take a look at the TechDB. And the TechDB has really been working itself behind the scenes. So if we go to the technology database, one of the things I want to show you is this where the intelligence resides? So this is what separates us from just a standard type of CAM system. For example, if we were to take a look at milling and take a look at our default operation parameters, you can see that for all of these different types of features that we find, we have different machining strategies already mapped out and set up. And not only that, but you can create your own particular machining and custom strategies as well. So you saw a lot of different rough mill strategies that we're using. And here you can go ahead and set that up. All these parameters for the roughing, the NC, feature options, advance and optimize, all of this information, including tool selection, spindle speed, etc. This database, there's quite a bit to it, but let's go ahead and let's take a look real quick at mill tooling, because also our tooling resides here. Probably a good one to look at. Let's take a look at some of our flat end mills, and you can see that a lot of the different tools that I was choosing today, and we wound up using just two different size flat end mills, a 3/8 and a 1/4 inch. All of those can be defined right here inside of the database. And then, of course, we can define those as a subset into what we call a tool crib itself, okay? So tool cribs themselves allow us to take a collection of the tools from the library and dedicate them to a specific type of machine. Very, very nice, very quick, and very easy. So that's just kind of a general overview of the tech database. It's what makes SOLIDWORKS CAM so intelligent, and what makes it gives me the ability to really do things much quicker and much more accurate than a traditional CAM system. Let's come back and let's take a look. So the TechDB, first of all, it is a SQL database that captures your company's machining rules. And that's exactly what it does. So the other thing that's important is that a single TechDB can be accessed by multiple programmers over the network, resulting in programming consistency and improved quality for everything that goes to the shop floor. Think of the TechDB as really a master machinist in a box. So your best-in-class tribal knowledge is actually pushed into the technology database, where it learns your machining best practices and then applies those to features across the board for every programmer, again, giving us consistency and improved quality. Next, let's take a look at post-processing. No NC demo would be complete without a little bit of post-processing. So let's take a look at that, and let's just jump right over. So before I begin with the actual post-processing, let me show you real quick what we've got in our machine parameter. Machine allows me to come in and define basically the tool cribs that are in the database, the TechDB, but it also allows me to choose from a list of post-processors. And you can see I've got a pretty good size list of post-processors that come with SOLIDWORKS CAM. Here I've chosen a Tormach 770. You remember that that's the machine that the process plan sheet guided us to use. And you can see that I've selected that. If I want to take a look at some of the information right here, I can just hit more and I can get some data about the post processor without having to go to the controller manual or look up external information. It's right here. The other thing that's nice is that if I go to posting right here, you can see that I can actually put in an O block number. So for this, I'm just going to put in, I don't know, 5209. Sounds like it would be appropriate. And let's just hit OK. Now, the actual post-processing is really simple. We're just do a right mouse button and just say post-process. And again, it just wants to know where we're going to put the text file, or what we call the G code. And I'm just going to save it right here. And then we're just going to go ahead and run it. And you can see the G code as it's created. It's actually, I can go back and I can look at it right here, although this is a little difficult and tedious. I can look at post-processor details. But the key thing is that when I hit OK, I can actually go in and launch our NC editor. The NC editor now is going to give me a place where I can really take a look at my code, and I can look at it line by line. So it is an advanced NC editor. Let's take a look at maybe some NC functions that we could do. We can adjust feed rates globally, speeds. Come back, I could find maybe the next tool change, and you can see it'll automatically go to the next tool change. Lots of different things we can do. If we come over here, there's also kind of a built-in DNC system into this so that we can send and receive. Also, too, there's back plotters built in so that we can come in and back plot our tool paths. And we can see this and make changes right here. You know, great capabilities. Again, this comes with every seat of SOLIDWORKS CAM standard as well as professional. The other thing that I'd like to show you is let's go back and revisit our drawing, because we did this post-processing, and I want to show you something that happened. So let's take a look at this drawing, and let's go back into our title block. And you can see our drawing is now updated automatically with all the posting information. It's got the actual name of the G-code file. It's got the name of the post processor that we used, the individual who posted it, as well as the date, as well as the machine being utilized. So great capabilities. I'm just going to come out, and you can see that we've got some great documentation that really just fell out automatically. So this is the power of being able to use an integrated system within inside of SOLIDWORKS. The ability to get all of these assets and this data creation almost automatically, and in a way that is based on the rules of how your company machines. Great capability. So now that you've taken a look at post-processing, let's just take a look and go over some of the benefits. There's a large supply of post-processors that ship with SOLIDWORKS CAM. There is the SOLIDWORKS CAM NC editor. And then there's also the universal post generator, which allows users to create and modify custom post processors. I'd like to show you that real quick. So let's take a look at that, and we'll go, let's just take a quick look at what that looks like. So the post processor generator is simply an executable that allows us to create and modify custom post processors. So we're going to open up one real quick, and you can kind of see it here. I'm just going to come over here and show you some of the basic sections. This is also where we will compile our post processors, but you can see we've got a machine. We've got a header that allows us to set up different types of behavior for our machine tools, a miscellaneous tab that also, and then also the ability for sections. So if I want to be able to control how an initial tool change looks, I've got different tokens and codes that I can use to do that. There's one for a subsequent tool change. So this is post processor, universal universal post processor generator, excuse me, or UPG, is available for everybody who is using SOLIDWORKS CAM Standard or SOLIDWORKS CAM Professional. So with that, we're just going to kind of wrap up. And I think we're running almost out of time. So with that, I'm going to take any questions. I think we've got about 7 or 8 minutes.
So John, I did answer a few questions from what I knew of CAM, and maybe we can pick 1 or 2 questions, and if maybe take the other ones offline. I do not want to go past the hour. So maybe a question with regarding the post. Can we insert a NC stop to allow the operator to flip the part in order to mill the other face of the part?
Yes, yes. In fact, you can do that right within the SolidWorks environment. You can add post comments, and typically an MO1 is one that an option stop is one that you can right mouse button on any operation and just insert that that operation.
Okay, so you don't need 2 different programs. You can do that all in one program.
Oh,
right?
Absolutely. Oh, yeah. And yes, I could. Yes, I
All
could.
right, so probably another question that in the same line is, can you add a manual code between operations?
I'm sorry, could you repeat that? You broke up.
Another question similar, can you add a manual code between operations?
Yes, you can. But typically, it has to be done through the post processor.
Okay.
And we are adding some more flexibility to that in 2019.
Good. Awesome. So there's a few other questions, but like I said, I do not want to go past the hour. So I think I'll just turn it to Joelle to do the closing comments. So thank you, John, very much for your help.
Absolutely. Thanks, guys. Thanks, Michelle. Thanks, John, for taking the time to be on with us today. We really appreciate it. That was a great overview, introduction to things that SolidWorks CAM can do. I think automatic feature recognition was my favorite throughout. So I always like things that are automatic, but obviously there's a lot of intelligence that goes into this process. So if you did notice at the beginning, John actually owns some CNC machines, or at least one, and keeps doing work with that on a regular basis. So hasn't lost his connection to that world, and we're grateful for it now as we've jumped into this world at SolidWorks. While we were at SolidWorks World, actually, this is a little video you're seeing on the screen now. We actually had a shop floor with a lot of machines, and you can see John in this particular part of the video. We've got a recording of this whole interview that was done. It lasted about 15 minutes. We're not going to play it today, but it walked through the shop floor that was completely installed at SolidWorks World. The whole idea was to manufacture a shifter for the Ring Brothers car. If you saw the video at the beginning of these guys who do some custom parts for cars, that's what the whole purpose of, and the walkthrough of the floor shop is to show you how that was done. So it's very interesting. You'll see the different machines that are listed here, inspection that can be done as part of the process. So the link is right there. If you go to live.solidworks.com on demand, you'll see everything from SolidWorks World. So if you scroll down, it actually goes backwards. Day 3, day 2, day 1. So just under the day 1 key note main stage session, you'll see this video, and it is definitely worthwhile going to see how all this comes together with different machines that can use the SolidWorks CAM. So very cool stuff. This session has also been recorded, so if you need to see it again, if you want to share it with anybody, it is accessible. There is a link. Here's all our recorded webinars that we do for Eastern Canada are on this page. So you can take a snapshot of this, or the actual link to register for the webinar will lead you back to the recording as well. So different ways of getting there. If you have neither of those, please don't hesitate. You can email us, Michelle, who the GoToMeeting link would have come to you from, or myself if you've gotten an email from me inviting you to this. So our emails are there. You've got some questions, contact us. We'd love to help you. Contact your reseller. Obviously, they're there to help you as well. Lots of resources, and let's see how these new solutions from SolidWorks can help you. And remember, if you have SolidWorks Standard, Professional, or Premium on subscription 2018, you have access to SOLIDWORKS CAM standard included into that bundle. So let's find out how you can utilize that today if that would be of help for you. Thank you for joining us today. Have a great end of your Friday and a great weekend, everyone. And hopefully we'll see you on our next webinars in May. Thank you very much. Have a great day.
And big thanks to John. Again, unfortunately, there were some questions unanswered today, so I'll tally every questions and I'll make sure that you get an answer. So thank you, everyone, and thank you, John.
You're welcome. Thank you all.
All right. Bye, everyone.